All right, so we're going to go ahead and do the Chapter 6 review for your test. Remember, this is a full chapter for the test. Questions 1 and 2 I've got done already. If you want to press pause and do those, take a look at those. Those would just take too long to do. Pause those. Remember, those are the values of x that my class uses. Your class might use different values for x. Number 3. It says in the 1990s, Austin's population was about 21,000. In the years following 1990, it increased by around 1.6% each year. Write a function model to represent. So in this case, our amount was going to equal our principal times 1 plus or minus the rate to the time. So we started out with a principal amount of 21,000 times 1. It's increasing, so it's going to be 1 plus. Now I've got to do the rate. Make sure your rate is now at a percentage, so it's 1.6%. Make sure you change that to a decimal. Biggest error on the quiz is that you didn't change that to a decimal. So remember, to move to a decimal, you need to go 2 places to the left. So that's 0.016 raised to the t. So there's our model. Now, it's telling us after 30 years. So we're going to take 21,000 times 1. I'm going to add that. So 1.016 to the 30th power. So you'll type that in on your calculator. Remember to hit the caret to get to your 30th. And your solution there is 33,808.8 people. You don't have the 0.8. So 33,808-ish, maybe 9. Question number 4. The principal interest rate of the compound period for 2 accounts are listed. Determine what the loan will be worth. Determine which loan will be worth more at the end of the time period. Make sure you show all your work. So we've got the first one is compounded continuously, and the second one is compounded quarterly. So for compounded continuously, it's A is equal to P times E to the RT. So I'll do this one on this side. So our principal amount for our first one is 15,000. Then we're going to go times E. Now again, our rate is 6.5%. We need to move it 2 places. So that's 0.065. Our T is 8 years. So times 8. Gotta erase that here for a second. It's not letting me erase. Oh well. Times 8. So 1,500, so second ln is going to give me my E. And then inside parentheses, 0.065 times 8. And that amount is equal to $25,230.41. So I'm going to keep that number in mind. Now we have to do it for the second one. For the second one, we'll do that in blue. The formula that we're going to use is A is equal to the principal times 1 plus our rate divided by n to the nt, where n is how many times it's compounded. So our principal is 12,000 times 1 plus our rate, so it's 4.8%, 2 places, 0.048, so 0.048 divided by n. Well, it says it's compounded quarterly, so that means our n value is equal to 4. So that's going to be 4, and then this is going to be 4 times the number of years, which is 7. So that's 12,000 parentheses 1 plus 0.048 divided by 4. And then I'm going to take that to 7 times 4 is 28. That number is $16,758.52. It says determine which will be more, show all your work. So obviously 25,213 is more. So account 1 will have more into it. And again, you'll have to show all of that work. It doesn't say how much more. It just says which one will be worth more. And you'd have to show all of that work in that problem. The next question, number 5, says rewrite each in exponential form. So our base is x to the y equals 194. And you're done. ln, remember that ln, another way we can write ln is log base e. So I could rewrite this log base e to the x equals 2. So this would be e to the second equals x. There's your solution. In logarithmic form, so we're going to go the other way. So this would be log base x of 79 is equal to y. And this would just be log, and you could put the base of 10 down there. You don't have to. So it'd be log base 10 of x is equal to y. And again, you can put the 10 down there. You don't have to put the 10 down there. Doesn't really matter. Probably more correct if you don't. Next one says evaluate each expression. So now that we know the change of base formula, we're going to use the change of base formula for this one. Change of base formula says that we'll take the log of 4.82 and divide that by the log of 4. So on a calculator, log 4.82 divided by log 4. Round to the nearest thousandth, so that's 1.135. And again, remember what this means. This means that if I take 4 to the 1.135, I should get 4.82. And if I just check that, just to make sure that's what I get, yeah, that's what I get. So the next one, same thing. We want to figure out 4 to what power is 2.5. So we're going to go the log of 2.5 over the log of 4. Log of 2.5 divided by log of 4 is 0.661. So there are your solutions for those two. Now, write in condensed form. Okay, so says write them in condensed form. So again, I'm going to kind of look and see. Okay, so I've got that 15 out front. So I could rewrite this as log base 3 of x to the 15th. I also notice that I've got this going on, so I'm just going to rewrite this as log base 3 of y to the 3rd. It's not in condensed form yet or as a single log. So now we need to do what we do when we subtract. So when we subtract, it stays log base 3. But now the of x to the 15th is going to be our numerator, and y to the 3rd is going to be the denominator for it. Okay, and again, this was just an explanation for it. If you can go from that first step down to that last step, more power to you. Second one, again, I'm kind of looking at what I've got. I've got 25 log base 4 of a, so I'm going to go ahead and rewrite that. Log base 4 of a to the 25th. I've got 5 log base 4 of b, so plus log base 4 of b to the 5th. Now I notice that we're adding, so our rule when you're adding is you multiply the ofs. And there's your single log. And we talked about how important it was being able to do the single logs. We do a lot of that. Now we're going to go the other direction with it, with questions 13 and 14. We're going to go ahead and expand it. So I notice if I kind of peek in here, I notice that I'm multiplying. So when you multiply, that means you add. So I would have log base 9 of x to the 4th, plus log base 9 of y to the 5th. Okay, but now I've got the power things going on both here and here. So since we're expanding it, I need to put those things out front. So it's 4 log base 9 of x plus 5 log base 9 of y. And that's your solution. Number 14. Number 14, I notice I'm going to a power. Don't know why I wrote over the top of that. We're going to a power, so I'm going to take care of that power first. So that's ln. Multiply the exponents, so that would be a to the 12th over, we also have to square that, so b squared. So we've got dividing going on, so when we divide, that means we're going to subtract. So ln of a to the 12th minus ln b squared. But again, we've got these exponents going on. Since we're expanding these exponents then, that means I can put them out front. So 12 ln a minus 2 ln b. That's your expanded form. All right, so the next ones we're going to solve. Looks like we're starting with exponentials. So remember, when you're doing exponentials, first thing is to make sure you isolate your piece of it that's to an exponent, so your base. So that's already done. So then we're going to go ahead and rewrite it as a log. So this would be log base 2 of 7.2 is equal to x plus 7. Now we can use the change of base formula. So the log of 72 divided by the log of 2. That's going to equal x plus 7. So we'll go into our calculator. Log of 72 divided by log of 2. That gives me 6.1699. Don't hit clear on your calculator. Equals x plus 7. Now we're solving for x, so we're just going to subtract 7, and you get negative 0.8301 is what your x value is going to be. And you're done. Number 16, again, look at isolating the base. Our base is already done, so we're going to rewrite it as a log. So this would be log base 8 of 53.2 equals negative 10n. So change of base formula, log of 53.2 divided by log of 8. Log 53.2 divided by log of 8. That's 1.9111 is equal to negative 10n. Divide by negative 10, and you get negative 0.1911. You're done. Number 17. Okay, so if I look at this one, here is my base to my exponent. So I have to isolate that. So I have 8 being added to it. So the first thing I need to do is need to subtract 8 from both sides. So that gives me 6 times 10m plus 3 is equal to 82. Now it looks a lot like questions 15 and 16. So that's what we're going to do. So we'll go log base 6 of 82 equals 10m plus 3. So this time I'm just going to kind of think about what I'm going to do. So I've got log of 82 divided by log of 6. That's going to give me a decimal. That's going to equal 10m plus 3. So then once I have that decimal, or whatever it is, I can subtract 3 from it and then divide by 10, and I'm going to get my solution. So that's what I'm going to do. I'm going to go log of 82. So this is a change of base formula. So the log of 82 divided by the log of 6. And when I do that, I get 2.4594. And I'm not going to write that down. I'm just going to kind of leave it like this. So that decimal, I'm going to leave it like that. I'm just going to go ahead and subtract 3 from both sides. So that gives me negative 0.54056. And then I need to divide that by 10, and that will give me my solution. So the solution to this is negative 0.0541 is equal to M. And it's down to 17. See how we did? Yep. Just checking the answers, make sure we got what they have. Looks like we're doing good so far. Now, number 18. 18, I'm just going to highlight my base and my exponent. So that's right there. So it looks like I have 4 being added to it and 9 being multiplied from it. So I'm going to get rid of any addition or subtraction first. So step 1, I'm going to subtract 4. So I get 9 times 8 to the 2x equals 43. Now I've got 9 times 8, so I need to divide both sides by 9. So you get 8 to the 2x is equal to 43 divided by 9. We're going to make that 4.78. So I'm going to, now I've got it isolated. So this would be log base 8 of 4.78 equals 2x. So that's the log of 4.78 divided by the log of 8 is equal to 2x. So in the calculator, log of 4.78 divided by the log of 8, and then I'm going to divide that by 2. I get 0.3762 for the value of x. Let's check the solution just to see how we did. Not bad. 6162, close enough for me, and should be close enough for your teachers. More than likely because I rounded here. This is kind of where that happened. All right. Looks like the next 4 or so, we've got logarithms. Okay, so remember we're doing logarithms. You have to have a single log equal to something. Okay, it's always a single log equal to something. So if we look at 19, we have a single log equal to something. So now, since it's in logarithmic form, we're going to put it in exponential form. So that's the same thing as 3 to the third is equal to x minus 7. 3 to the third, 3 times 3 is 9, times 3 is 27. So that's 27 equals x minus 7. Add 7 to both sides. You get x is equal to 34. Question number 20. Again, we're looking for a single log equal to something. We've got a single log equal to negative 2. So we're going to rewrite it. 5 to the negative 2 equals x minus 3. So I'm going to do 5 to the negative 2 on my calculator. So 5 caret negative 2. That's 0.04 equals x minus 3. Add 3. There's your x value. So question number 21. I said we have to have single logs. So we've got 2 single logs. These single logs have the same basis. So remember, if you have 2 logs with the same base, this is log base 14 and log base 14. If their bases are the same, then their ofs have to equal each other. So I'm going to add 10. So that's negative 5x equals negative x plus 20. Add x, so negative 4x equals 20. X equals negative 5. There's your solution for 21. Question number 22. Okay, I've got kind of this expanded log, and we can't have that. We've got just 1 on the other side, so that's good, but we've got an expanded log, so we have to write that as a single log. So we're subtracting, so this would become log base 7 of x squared minus 2 over 2 is equal to 1. Now we have a single log equal to something, so we're going to write it in exponential form. So 7 to the first equals x squared minus 2 over 2. Well, 7 to the first is just 7. So I need to multiply both sides. Since we're being divided by 2, that means I need to multiply by 2. So 14 is equal to x squared minus 2. Add 2. So that's 16 is equal to x squared. And now take the square root of both sides. And you get x is equal to 4. Or x is equal to negative 4. There are your solutions. Remember, when you take the square root of something, it's either as positive or it's negative. Let's make sure that puts that 4 or negative 4. Look at that. It's like I know what I'm doing. All right, number 23. Again, we have this log. They're being subtracted. So that means we got to divide again. So this is log base 5 of x squared minus 9 over 8 equals log base 5 of 54. So they have the same log and base there and there. So that means their ofs have to equal each other. So x squared minus 9 over 8 is going to equal 54. Multiply both sides by 8 to get rid of the fraction. So that's x squared minus 9 equals 54 times 8, which I have no idea what that is, 432. Add 9 to that. X squared equals 441. Take the square root of that. Square root of 441, I believe, is 21. So x is equal to positive 21 or negative 21. Double check. Yay. Number 24. Again, got this log, another subtraction one. Should be getting good at rewriting these. So this would be log base 4 of 5x over 3 equals 3. So we've got a single log equal to something, so we got to write it in exponential form. So 4 to the third equals 5x over 3. 4 to the third is 64. So 64 equals 5x over 3. You have to get rid of division again. So we're going to multiply by 3. So 3 times 64 is 192. That's equal to 5x. Divide by 5. So x is equal to 38.4, or 192 over 5. Same thing. Double check. 38.4. Next one. Okay, so we're subtracting again. So we're going to write it as a single log. So this would be log base 5 of 5x squared over 4 is equal to 3. It's in logarithmic form, so exponential form. So 5 to the third equals 5x squared over 4. 5 to the third is 125. Oops. Equals 5x plus 2 over 4. Multiply both sides by 4 to get rid of that fraction again. So I'm going to have to do this up here, running out of room. So 4 times 125 is 500. So we get 500 equals 5x squared. Now we got to divide by 5. You get 100 equals x squared. Take the square root of that. You get 10, or negative 10 is equal to your x value. And the last one, number 26. Okay, again, we've got this that we have to condense, but we've got an adding this time. So since we're adding, probably don't want to use a highlighter. Go log base 7 of, I'm going to put it in parentheses, x minus 1 times 8 is equal to 2. Write it as an exponent. 7 squared equals, and I'm just going to go ahead and distribute that. 8x minus 8. So you'd have 49 equals 8x minus 8. So 49 plus 8 is 57 equals 8x. Divide by 8 to get a decimal. X is equal to 7.13. Here's your value for x. We'll go down there and check it. 7.125. I probably should have done, they said nearest 10,000th. By that time, I forgot what the directions were. So I should probably go back to what the directions were. And they say to the nearest 10,000th. Make it 7.125. So there is the review of Chapter 6. I hope you enjoyed. Good luck on the test.